that to it. Write down what you get. You don't have to get it from me. What was your product? Okay, what you expect is that this nitrogen is going to do what? It's going to attack carbon, yes. And, okay, yeah. Also. And then what? Then what happens? One of the lone pairs of which ones attacks the hydrogen? Okay. And? Okay. Is this going to be an acetal?
No.
Like it was with the oxygen or with the sulfur?
No.
No, it is not going to be an acetal. Okay. It is going to give you. So you write down whenever you use nitrogen, but this is not all the time. Whenever you use this here is called the hydroxylamine. Okay? Hydroxylamine. So whenever you use hydroxylamine or a primary amine, you are going to get a double bond to that nitrogen. So, that's what you get. Okay? Yes, double bond to the nitrogen. So, what you do is, you look at the carbonyl, yes? Nitrogen containing, this is not the same thing as acetal, hemiacetal. Okay? It is the same, it's just going to happen twice, and you're going to form a double bond to the nitrogen. Okay? And you are going to take hydrogens out from the nitrogen, and you are going to put an OH. How many hydrogens out of the nitrogen? 2 hydrogens, yes?
Yeah.
So 2 hydrogens went out, and it made a double bond to the carbonyl. This has a special name from hydroxylamine, and the name of this is oxime. How can you remember this name? Ox seems like ox, yes or no? With the oxygen here? And I means like amine, yes? So there's an oxygen with an amine, oxime. Now tell me the product of this. What? A what? Yeah, but I don't know what that word means.
The double bond to the
Describe
end with
the
the
same
CH3.
No. Carbon double bond to nitrogen. Outstanding.
Methine? I don't know.
Carbon double bond to nitrogen. That's what I know. Yes.
Yeah.
Instead of this oxygen, what is it going to be? And nitrogen. Yes.
Yeah.
and nitrogen. And this nitrogen, what does it have on it?
CH3.
CH3. What happened to the other two hydrogens?
They're gone.
They were removed in the process, yes?
Uh-huh.
They were removed in the process.
Methine.
And this has a name too, and the name is? I mean, you mean what? This is imine, okay?
Oh, okay.
Imine, okay? I mean, it's complicated.
I mean.
That's okay. We don't speak English in this class, so we're gonna call it imine. Okay?
Amy.
And this other one down here, what is it going to be?
Amine. Right?
No, don't be looking for it. It defeats the purpose. Who?
Amine.
Amine?
Amine with an E. With the E. With the A. So large.
Okay, tell me. Carbon to what?
Double bond, nitrogen.
Absolutely not.
Not. No, because there's no. It's no two
Does this have
H's.
two hydrogens
It's just
on it?
one H. Yeah.
CH3.
I'm asking, does this have two hydrogens on it?
No.
It does not have two hydrogens on it. It cannot form a double bond, can it?
No.
How is it going to form a double bond? It does not form a double bond. So the nitrogen with what
There's
else?
two CH3.
With the CH3 and
CH3.
the CH3. You can only make
That's it.
3 bonds on that nitrogen.
Yeah.
And now what is going to happen is there will be a double bond down here to one of the carbons on the side. Okay, to either this carbon or to that carbon. And what's the name of this? Amine? Yes. Amine?
With the E. No, with Amine.
This is called an enamine. Enamine.
That's not what Rich said.
Okay, whatever, okay? Doesn't matter, guys. Okay? This is an ene from where? From an enol, yes? Like an enol, you remember an enol?
Yes.
It was an ene with an alcohol, yes? This is ene and the amine, yes? So it is a double bond and an amine. Guys, what's confusing you? The name is confusing you? What's confusing you?
Who says confused?
Oh, okay. I thought somebody was confused. So let's do one like this. See what you can get. Okay, so what's gonna happen to this one up here?
What we call it? Cyclic? It's gonna be cyclic?
It is going to be cyclic. You notice here is an aldehyde.
Yeah.
An aldehyde or a ketone, doesn't make a difference. And here you have an amine. Yes, it's not separated. It's the same. It's part of it. You have to know that this is going to undergo an intramolecular cyclization. Yes. So
It's a
how
three-member
many?
Four.
Yeah. 1, 2, 3, 4.
The ring.
It's 4. The ring is 4
Ring is
members.
going to be how many?
4.
5
1, 2, 3.
5.
You say 4, raise your hand. You say 5, raise your hand.
Cyclization is going to happen between.
Carbon and.
Guys, I don't know if you realize it.
That's
Between this and this, yes? That's one long bond, yes?
5.
So I'm going to say 1, 2, 3, 4, and 5. That's 5. The ring is 5. It has 4 carbons, but it's 5.
And the NH2 is on the inside.
So I am going to draw a 5-member ring without caring where things go. Okay? I don't know where things go, and it doesn't matter to me. But let's say that the carbonyl was here. Let's say that this is this one. And now, okay, some of you will think it's a radical, okay? So let's say that that is where the carbonyl was. Do I have a carbonyl?
No.
There's no more carbonyl. The carbonyl is
Gone.
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 There will be a double bond to what?
NH2.
To a nitrogen. There will be a double bond, and this will be a nitrogen there.
On the inside. Why not? Oh, because it's not on the, oh,
Why
it's
not
on the
like
end.
that?
Because it has to stay on the inside.
Like this?
No, not like that.
How?
That will be 5 carbons then.
Yeah, that's 5 carbons. That doesn't have 5
Not
carbons.
like that. It has to stay on the inside. Okay.
Yes or no? It's looking a little weird, huh?
Yes.
I don't know how you guys are going to deal with this. This next exam, that's why I gave such an easy exam this time. Because the next one is going to be nice and juicy. Okay, let's do this one. What is it? You want more? Okay, no, she wants more. Let's do another. It's the same thing, huh? Guys, you gotta do that one down there and this one up here. I'm giving you time, but I'm wasting the time, okay? We need to move forward. So, tell me, what are you gonna get here? It's still going to be 6-member ring, yes or no? Yes. But now you have, what type of amine is this?
2 of them.
It has 2 hydrogens, yes?
Yeah.
Because it has 2 hydrogens, it's gonna give me a double bond, yes? It's gonna give me a double bond to the nitrogen. Okay, this is outside, this was not an intramolecular cyclization. So, instead of the oxygen, I put what? A nitrogen. And what else does it have on it? NH2. That has another fancy name, which is called, who knows? Maria. What's the name of it? Perfect. Hydrosome. You got it. I'm surprised you know it. Why are you so quiet today? You having a bad day? Of course.
No, I'm not having a bad day.
Oh, okay.
Slow start.
Yeah. So if the nitrogen has 2 hydrogens, what is it always going to give you?
A
Double bond to, from replacement, double bond to the carbonyl, yes, used to be the carbonyl. If it is a secondary amine, what are you going to get? You're going to get single bonds to the nitrogen, but you're going to get a double bond somewhere else, okay? And the double bond will be starting on the where it used to be the carbonyl. And the name of that is enamine, yes? Okay, guys. So what is it for this one? That's called the hydrosome. What is it for this one?
5 ring.
Which one? 5-member ring? How do you know? 1, 2, 3, 4, 5. Kind of like what we did before. I'm going to draw a 5-member ring and I'm going to figure things out after. Okay? Let's say that the carbonyl is this one. It's going to make a double bond to the nitrogen because it has 2 hydrogens, yes? What else?
We have,
It has a methyl.
What was here?
But it's.
This is where the carbonyl used to be, yes?
Yeah.
That had methyl. And what else?
The other method. But
And this is complicated, yes? 1, 2, 3, yes? On the third carbon, 1, 2, 3. This was the first. So 1, is this 2?
No.
It's not a carbon, it's not even a carbon.
yeah.
So 1, 2, 3 is here. How many bonds away from the nitrogen?
2.
Okay, 1 and 2 bonds. 1 and 2 bonds, okay? Excuse me?
I see why.
Because the first one didn't have a methyl group. The first one is from over there.
Is there a name for it?
What? The name for what? For this one?
Yeah.
No, there's no name. This is what's it called? Amine. Yeah, this is like an amine, I guess.
I mean, no special name, like hydrogen.
No, I mean, hydrosome. When is a hydrosome, guys? Hydrosome when it has a nitrogen here. Oxime when it has an oxygen there. Okay. Imine is when it has what there? A carbon. So that would be. Would that be an oxime?
No.
No,
Would that be a hydrosome?
Nope.
no,
No. Would that be an enamine?
no.
No. That would be imine. Amine.
Are you
Okay.
doing naming
What?
Are you doing naming something?
We did naming already.
Yeah, but are you?
Like naming of this? No, just you don't have enough with the reactions.
Oh, I see.
Let me see what problems I have here, my friends. Oops, I don't even know where I'm at. Okay, let's see this one. Provide the product to that. What time is the class over?
20 minutes.
11:30.
I think that's the product. The first one's the product, right?
What?
Is that the product?
No, this is, okay,
Part of
this
the
is, yeah, this is the reactant.
Oh.
Yeah, that was confusing, huh? Nice shoes.
Thank you.
Why are you laughing, Sophia?
I hate Crocs.
It's a weird looking thing. Crocs with gym clothes, with medical stuff.
I had a rough night.
You had a rough night? All right. So here's what we have, yes? 6-member ring. Does it destroy the 6-member ring? No. What does onolysis do? Cleaves. Very good. And what does it form?
Aldehyde, 2 hydrogen.
Well, it depends on it depends on the double bond, yes? Okay, very good. I'm impressed. So, what are you going to do? What type of amine is this? Primary, secondary, tertiary? Secondary. Secondary amine, is it going to give you... Is it going to give you an imine?
No,
It's going to give you an enamine. So I am going to write a single bond, and to that single bond I am going to place what we had from before. Maybe that's easier for you to understand than the other one, yes?
Yes.
Okay. And then now what? Double bond somewhere. Where? Where the carbonyl used to be. That way or this way. Okay? Now I'm not showing you, if you had a methyl group there, I'm not showing you where it goes, okay? You give me a double bond, I'm going to do it symmetrical. Okay? If it's not symmetrical, I might have 2 products. But I'm not going to get there. How about this one? Can you do this one? This is like Batman all over the place. So here it is, right? I'm going to do that and that. You agree?
Yeah.
And now bond to nitrogen that has more bands. Yes or no?
Yeah.
Now the double bond somewhere, the double bond here, right?
Yeah.
No. It's not there?
Nope.
It's not here? Where is it? It is on the carbon. It is on the where the carbonyl used to be. You always count the number of bonds. Yes, this carbon has 1, 2, 3, 4.
How do you figure out what a double bond is supposed to be?
You got to put it on the carbon that the carbonyl used to be at. Why don't you guys go together so you can chat on the way? Okay. Let's do this. Here's this. And what is that going to give you? What is it called? An enamine?
No.
Huh? Oxide?
No.
Hydro. Hydrozone. Autozone. Nitrogen, yes? And more nitrogens. And then, let's see, is this nitrogen happy? It looks like it lost 2 hydrogens. Is that okay? It has 1, 2, 3 bonds, has that lone pair. Okay, she looks happy. That's what's important, okay? Now, this is special, okay? And the reason why this is special is because you notice here is a bond between a nitrogen and another nitrogen. It is always best, whenever you see a nitrogen next to another nitrogen, what likes to form is this thing will, in general, decompose to form that N2. Okay? So this reaction is called Wolf-Kishner. Kiss the wolf. Okay, Wolf-Kishner. How do you spell wolf? Now you want Kishner? Okay? Yeah, everything is German, isn't it? Well, right now, no. Right now, everything is Chinese. Even I was made in China. But yes, long ago it was all German. So yes, this were, I think it were German, maybe Austrian. Okay? And what this does is, in the presence of a base, okay? And the base is like potassium hydroxide and some heat. This is going to give you what is that similar to? Oh. Of course, potassium hydroxide and water, yes? And heat. What does that look like? Was there another way you could have done that from this chapter? With raining nickel. You could have done that with raining nickel. And for you to use raining nickel, what do you need? The protecting group, which is, well, like the Bart Simpson, yes, but with sulfurs, yes? Okay?
So the raining nickel only works with sulfur?
Only for sulfur. And this is only for that. Wolf-Kishner. Okay. And this is what type of group is this? Is this an oxide?
Hydrogen.
This is hydrogen.
AutoZone.
You get all the parts then. I'm not going to be able to finish the chapter the way I want it. What am I going to do?
Are we in the base?
Okay, let's do something simple. Okay, let's say that I have here lithium aluminum hydride, yes? This is a source of what?
Hydride, right?
H minus, yes? What is that going to do?
Attack.
That is going to attack. What is that going to do? This is the Mickey Mouse mechanism, okay? This is not the real mechanism. The real mechanism has a lithium here bonded to this, and depending on what metal, this is what I care about, that you know that this nucleophile is going to do what? Attack there. Now, these conditions, are they in the presence of an acid?
No.
Like Brunstad-Lowry acid? No, this is H minus, okay? So this is going to go like that, okay? And what you are going to have is, now the O minus up there, and you are going to have the groups that you had from before, and now this H. Okay?
The 2R and the H.
Yeah. You know what? Let's put CH3s here. Yes? Put CH3s here, CH3 here, CH3 there, and a hydrogen. Now, does this reaction look like it is reversible? If this were to be reversible, what would need to happen is something would need to leave.
Yeah.
What's a good leaving group? CH3?
Water.
CH3?
No.
The H, a good leaving group?
No.
Water is a good leaving group. Do you see water on it?
Well, you can make water.
You make water? No. So what you are going to do is you can add water. You can even add acid to this. And what it's going to do is it is going to protonate this alkoxide. Yes, that's what that's called. An alkoxide. To form the alcohol. And this is what you knew from before, yes? Ketones and aldehydes get reduced to alcohols using what?
Lithium.
Using lithium aluminum hydride or sodium borohydride. Okay. Let's do this reaction then. Let's say I have this. And I treat this with CH3MGBr. What's that called?
Grignard.
This is a Grignard. Grignard? Is that spelled right? Grignard? Why do they call it Grignard?
G silent.
The G is silent in what language? Not in my language. Okay, that's a Grignard reagent, yes? And that Grignard reagent is a source of what? Nucleophile, in this case CH3 minus. What's going to happen is, that is going to happen first because the CH3 minus attack there, and this one like that. And now, once again, what's going to happen next?
Water.
You are going to add water. Because
Need to get
under
protein.
basic conditions, you need to protonate this, yes?
Yeah.
So,
Oh my God, I'm tripping.
what? En lasaña de G side. All right.
That's because it's not English.
What?
Lasagna. It's a ñi, just like gnocchi.
Very nice. Thank you so much, Sophie.
I'm usually Italian.
Okay, guys, let's so reaction of a carbonyl with that. Let's say now you have something with, let's say, potassium cyanide with from HCN, but HCN is cyanide, yes? Cyanide is not so good for you. Like, you do it in the lab, you're about to die, type of thing. What is going to happen now? The nucleophile, which is C minus, is going to attack, and what you are going to get is overall okay, let's say you're going to have an H plus there. I mean, you have HCN, so you have H plus. You like that, yes or no? What can I do with this cyanide? Kill someone, yeah. What is that called? That is a cyanohydrin, yes? Cyanohydrin, OH and CN. Cyanohydrin. What can I do with that reaction? Can I do a reaction? Do you know any reactions from organic 1 with CN? What were they?
NaCN and water.
Yeah, that's one too.
No, reactions of CN. Didn't we have a reaction with, let's say, reduction? Yes? Reduction. Let's say if I do a reduction here, what do I get from here? We have a triple bond here, yes?
Yes.
Reduction means the triple bond is gone, yes? On oxidation, you put oxygens. Reduction, you put hydrogens on it. So if it's a reduction, what do you get from there? You get an amine, yes? You get a CH2 here and an NH2 there. That could be done, let's say, what seems like a reduction for you, like hydrogen and palladium, for example. We'll do that reaction. okay? Did we do one in which CN is converted to a carboxylic acid? We did not? You sure? Guys, you gotta tell me when it's time to go, okay?
Right now, say great.
Oh, forget the test.
Like, you just get it. Like, you just get it. You're like, okay, listen.
Guys, what do you get from here? So lithium aluminum hydride is what? Reducing agent. What is it going to do to the CN? It's going to add what? Hydrogens and hydrogens and hydrogens, okay? I mean, this is not something that is new to you. I don't know how long I have been saying this. CH2, NH2. Yes or no? If you add an acid, water and an acid, what you are going to get is a carboxylic acid. Are you sure I did not do this? I don't believe you.
No, you didn't.
An organic one, I did an organic one. You sure?
Why can't it keep reducing the OH?
Hmm?
Why can't it reduce the OH? Does it already have an H?
Yeah, because already. I mean, for you to take that OH out, you have to eliminate it. Guys, how do I go from this carbonyl to this? From
AMNO4.
no, from a carbonyl to no carbonyl. I don't want rainy nickel. I don't want rainy nickel. And I don't want who?
Zinc, mercury.
H2 and PD? No, H2 and PD will reduce it to the opposite. We did this reaction for this test you took. Zinc, like the zinc amalgam, yes?
Yeah.
Zinc and what else?
HCl and HCl.
HCl. You know 3 ways, okay, of going from a carbonyl to that alkane with one single step, okay? One of them is Wolf-Kishner. The other one is who? The zinc.
Clemenson.
Yeah, it's called Clemenson. Did I say it was Clemenson?
No, not today.
Okay, Clemenson, whatever. Wolf-Kishner. Who else? Okay, I'll give you the test next class, right? You don't want it today.
Yes. Well, no.
Guys, on Tuesday, we are going to finish this chapter. We are going